Hello, we are at the second part of building Linux from scratch. We have started from Vim, so chapter 8.73. As a reminder, we're inside a LFS Linux from scratch root. We're as the user root. Inside the directory sources, we have downloaded the source code release tarballs for various projects. And for each of these projects, in this case starting for Vim, we have some steps that we'll do for each of these tarballs and then special steps that we do for each individual tarball. Let's start with the steps that are the same for most packages. We're inside the directory sources. We need to find the tarball for Vim. It's as expected, all lowercase, Vim, and then a version, and then .tar.gz. So this is a tarball, an archive. We need to extract it, to unpack it. Tar, the same command line, xvf, so x extract, v verbose, and f file, and then the file name, vim, ending with tar.gzip. A new directory is being created, vim minus and then a version. We need to change into this directory. And then we need to perform the steps that are specific to just Vim. And the steps are these parts. So the command lines which are shown in this type of styling. The configure step. For the case of Vim, it says that the build time, so running all of the commands that I'm going to run, which are specific to just Vim, are going to take 3.7 SBUs, and we have measured that one SBU is actually 1 minute in my case, in this setup that we have here, which is a virtual machine with 14 vCPUs and 20 gigabytes of random access memory and NVMe. Make will compile. Maybe it's 3.7 minutes because it's running the test suite and we're not going to actually run it. So we're not going to use the user named tester. We're not going to run the tests. We're just going to install the Vim text user interface text editor. Okay, let's create a symlink from VI towards Vim. And documentation. Okay, so that was the part for Vim where we have built and installed. Now we need configurations. Again, I'm going to just select whatever, all of the text that exists in this type of style in a box with a black border and gray background. Copy. I can paste with Ctrl-Shift-V or with right-click and paste. Or I could not use copy-paste, not use the clipboard, but actually use the primary. Okay, let's see what it says in here. Vim runs in VI incompatible mode. Documentation for other available options can be obtained by running the command vim-c :options. Spell checking for English US. So probably we should stop here. So I'm not going to run this command. Okay, and the results of this package inside /usr/bin, we will have the executable that we want, which is vim. Then we have a symlink vi, and that's it for the steps that are very special to vim. Now we'll need to continue by running the steps related to this package, to vim, but steps that are the same for most packages, which means go back to the sources directory. I'm navigating to the parent directory, cd ... and then I need to delete the intermediate directory, the one where we extracted the tarball. So that's rm-rf, and then vim. I use autocompletion by pressing the tab key. And that's it with vim. We're advancing to the next chapter, 8.74, markup safe. Thank you for subscribing, joining, and helping this YouTube channel. Let's find the markup safe tarball. It's all lowercase. Unfortunately, a very small number of tarballs are not all lower safe in a name. And this makes it sometimes hard to find the correct tarball that we want to extract. xvf, markup safe, cd, and then the instruction 0.1 SBU, that's less than 10 seconds. It's a PIP package. For PIP package, mostly the first command line is very similar. PIP3 wheel -w dist -- no cache dir -- no buildings isolation -- no depths, and then the current directory. And then there's a second command line that will install. The first one creates a binary package, and then that's being installed at the second command line. PIP3 install no index find links dist markup safe, the name of the package that we just generated. And then the PIP package will get installed into the correct directory /usr/lib python 3.13/site-packages. Next up, Jinja. So go to the parent directory. Extract Jinja. (0.1 SBU, less than 10 seconds. 1, 2, go to the parent directory, clean up, systemd, 1 minute and a half. What's the name of the package? Systemd without the man pages. Hopefully this is the one. So tar -xvf systemd 2. Remove two unneeded groups render and sgx from the default udev rules. Intermediate build directory, and then we're using meson. Home D disabled. user DB disabled. Okay, then compiling using Ninja. And then there's tests. Maybe this command line is going to be useful in the future where we create /etc/os-release file. So I'm going to probably run the test, maybe not wait for the full minute to finish. We'll see. So probably I'm going to run this command line block. Okay, so that was indeed fast. So we're creating the /etc/os-release file with a single line in there, name equals Linux from scratch, and then we're running the tests. Okay, so I can see 1650 tests, and we're halfway through. Okay, so the very vast majority of the tests have passed, and they're successful. One has failed, so I feel confident. Let's install. And have the man pages installed in /usr/share/man directory. Create the file /etc/machine ID. Set up the basic target structure. So it creates some system D configuration files, .service files, .socket files. Okay, so systemd is the init system, but also it's udev, the hardware probe mechanism where you insert a USB device, a new device will be created in the /dev directory, for instance. There's also the logging functionality, the functionality to reboot, power off, shut down, suspend to memory, suspend to disk, and many, many more. DNS resolve, the mounted partitions. Okay. And the next up is dbus. So go to the sources directory. We need to go to the parent directory twice. Delete the directory systemd and then the version. Dbus. Intermediate directory and then meson. So dbus is an IPC inter-process communication mechanism. It's used for when we have different executables or different processes and they want to talk to each other. For instance, if a graphical user interface application has the functionality to only allow one instance of it, for instance, a text editor such as Kate, when you start a second text editor, it will actually reuse the first process, the first window, and it will add a new tab in the existing window instead of starting a new separate process with a new main window under certain circumstances. Similar things for a web browser. When you have the web browser open and then you navigate to a new web page, for instance, from the command line, and instead of having a new Firefox window start, it will just create a new tab in an existing Firefox window. And other types of communications. Also communication between a user visible application and background applications such as daemons or services. Okay, so we did the configure step, which is Meson. Ninja, which is build, similar to the make step, and the Ninja install, similar to the make install step. /etc/machine-id. Okay, dbus is also something similar to Windows DCOM process activation, where inside of your process you're creating a object from an interface, and that object is actually going to be served from a different process, and then that process needs to be started with the correct command line, and then that process will export a object that gets instantiated, and that gets marshaled through the IPC marshalling mechanism in dbus from one process to another, such that one object resides in a process and the callers of the process reside in a second process. Next up, the man database. Very fast, less than 30 seconds. Configure step. We're going to run the compilation make step. We're going to skip the tests, make check, and go straight for make install. And we're not interested in other languages than English US. Apropos, man executable, man space -k. Okay, next up, proc ps ng. Okay, configure step with systemd. We're using the kill command from the util Linux package, not from proc ps ng. Make. We're not going to run the test suite, and make install. Okay, so the executables provided by this package: free, ps, top, uptime, w. These are the ones that I have used previously. Clean up. Util Linux. The configure step. Disable run user, set priv su no login. Okay, let's compile using make. We're not going to satisfy the tests by creating a dummy/etc/fs tab file. We're not going to run the tests. And then we're going to install the package. util Linux, some of the executables that I have used before, cfdisk, dmessage, fallocate, fdisk, fscheck, yeah, so the very vast majority of these executables I did not use before. I have used kill, lsblk, makefs, make swap, more, mount, renice, swap off, swap on, umount, and that's about it. Okay, e2fs progs. Intermediate build directory. Configure step. And next, make. We're going to skip the test suite. Install the package. Make install. Remove .a files. Info. Info is an alternative to man pages from the GNU project. Default options for make e2fs. If you need such a utility, you may remove the feature from the default ext4. Cannot recognize the ext file with meta sysum feature. I'm not sure. So this sounds like something that's optional. I'm not going to use make e2fs. So I know. I'll skip this command line. e2fs progs. I haven't. fscheck ext. Make fs ext4 and 2 and 3. And that's it. I didn't resize or tune the file system. Next up. Okay, there's an intermezzo in here. We stopped building packages and now we're talking about debug symbols. We talk about stripping the debug symbols out of the executable files, out of the ELF files. This section is optional. If the intended user is not a programmer and does not plan to do any debugging on the system software, the system size can be decreased by 2 GB by removing the debugging symbols. Okay. I'm actually not going to strip anything out of the existing executables because we have more than enough space. We have 200 GB of NVMe in the larger disk and partition of the virtual hard disk. Okay, so let's finish with this chapter with e2fs progs. Change to the parent directory twice. Clean up the directory. I'm not going to strip the debug symbols, but you just run this block as usual, the entire block. Cleaning up. I'm not sure what this thing does. .la files. The intermediate compiler that we don't need any longer. We didn't actually create a user tester. Next up, system configuration, network configuration, hostname /etc/hosts. Let's see. There's a systemd part that's called systemd-networkd. There's systemd-resolved. Both services are enabled by default. If you will not use systemd-networkd for networking, or if you're going to use network manager. Probably network manager is not part of LFS. Letter N. Nope. If it's part of BLFS and if we're ever going to install BLFS and network manager and a desktop environment that requires network manager, then we probably want to disable the systemd-networkd. Okay. Okay, so these are actually very optional steps. If we want to have /dev/eth0 instead of /dev/enp2s1 for the main Ethernet network interface card of the virtual machine, but we don't. I can survive with very long device names for network interface cards. So I'm going to just ignore this chapter altogether, network device naming. We're going to go to static IP configuration. Name network device name. Domain. Okay, so if we're going to rename the network interface card device name to /dev/eth0, then we know what to place in this placeholder with network device name. Probably. So these two chapters, static IP configuration and DHCP configuration, are actually alternative. You should choose between either just this or just this. In my case, I'm going to use DHCP. It's a virtual machine. There's a DHCP server in the virtualization software in Virt Manager, libvirt. And the only thing that we need to specify is the network device name, which I don't know how to do. Either /dev/ and then the name of the device, or just this short version. So let's edit this text in a text editor. Hopefully this is the way to do it. Just a very short name, not /dev/enp1s0. Probably the same device name will be inside the LFS system when we're going to boot inside the LFS system. Let's run this command. Creating the /etc/resolve.conf file. This is best achieved by placing the IP address of the DNS server available from the ISP or network administrator into /etc/resolve.conf. We're going to go the hard route, which is systemd everything. We're not going to have a static resolve.conf file. We're going to actually use systemd resolved. So we will not disable systemd resolved. Systemd resolved will see that there's no file /etc/resolve.conf. So it will create a symlink from /etc/resolve.conf towards /run/system/resolve/stub-resolve.conf. We'll see if DNS resolve doesn't work. We'll read on some documentation about systemd resolved, and we'll see how systemd resolved can be configured. Hopefully it uses the gateway that's provided by the DHCP server, or maybe the DHCP server provides a DNS server for IPv4, and that's being used by systemd. Okay, and then we need a host name. Okay, so we want the computer name and the virtual machine name to be LFS, all lowercase, like this. So it should not be in FQDN format. So without any dots, just the name, not the full path, LFS /etc/hosts. Let's see what's proposed. So it doesn't say anything about local loopback IPv4. It says about local loopback IPv6. We're not going to have aliases. Localhost, local domain. Okay, so says that we should not put in /etc. There's a special mechanism for localhost, localhost.localdomain. There's this NSS module, NSS my hostname. I don't know. So I'll take this content for the file, and we'll remove the line that specify a fixed IPv4 address for the most important network interface card of the virtual machine, the Ethernet one, because this is going to come via DHCP, so I do not know what IPv4 address will be used by this virtual machine. I'm actually not eager to use IPv6, so I would not add these lines either, but I'll keep them. Ctrl-Shift-V. We'll fix networking after we boot the final machine. devfs sysfs udev d mod info mod probe. Okay, we're not using any special hardware, any out of 3 kernel modules. We're not using NVIDIA GPUs. We're not going to blacklist anything. We don't have ALSA problems. Managing devices. We don't have a USB web camera, a TV tuner. We don't have duplicated devices. For the NTP client, the Network Time Protocol client, there's a systemd minus time date D. Configures time zone and system clock. On the first boot, if /etc/edge time is not exist, this file does not exist, there's a process systemd minus time date D that will think that the hardware clock is set to UTC, which it is. We have run this command and we see that the time zone is 2 hours behind the local time, which is UTC. So hopefully I don't need to do any of these steps because my hardware clock is not set to local time. Okay, network time synchronization. There's another module in systemd minus time sync D. So time date D is not for the NTP client. I don't want to disable it, hopefully. The system clock is not set to local time. So I will skip this part. Configuring the Linux console. Systemd minus vconsole minus setup. Virtual console font and console keymap. I don't want to use the Terminus font. I don't want to use the German keyboard. I don't want to change the locale. Configuring the system locale. Okay, char maps can have a number of aliases. Okay, so we want to use the most default possible, which is NUS UTF-8, probably. And we want to find the default alias, the preferred locale. UTF-8. Okay, interesting. Okay, so this says that I should prefer the most canonical name, which is all uppercase UTF-8. So not like this, but like this. Okay. And then I should run this command block. American English UTF-8 USD and whatever the int prefix is. Okay. Then we need to create a /etc/locale.conf file. This is this part. No modifiers. Okay, so in here it says that if the term is Linux, which probably means one of the 6 VTs, virtual terminals, the ones that you get to if you go Control Shift F2, F3, F4, we'll want to not use UTF, we'll want to not use English US, but C, the C programming language. Okay, I'm not sure what that means. So says that from /etc/locale.conf, which we just created, it's going to extract the language, the environment variable lang all uppercase equals, and then NUS UTF-8 with the correct capitalization. /etc/profile is used for configuring /bin/sh if that's not bash, and /bin/bash. And it's not per user, it's per the entire system. Okay, locale ctl set locale lang enus UTF-8 rc type nus. Okay, so these two should not be executed now because there's this note that locate ctl will not work in the chroot. And then there's no need to because we have configured /etc/locale.conf correctly. This locale ctl set minus locale is for editing /etc/locale.conf. Okay, input rc for the GNU readline library. Hopefully it's the default settings that I'm used to. Nothing needs to be configured. There's no placeholders for optional or things to replace. Less than characters or square parentheses. /etc/shells. We only have /bin/bash installed. Disabling screen clearing at boot time. Why would it do that? Disabling tmpfs for /tmp. There's a /tmp directory that's a tmpfs, which probably means that it's going to be lost when you reboot. I don't have a separate /tmp partition. I'm just going to keep the defaults. Automatic file creation and deletion. The syntax for /usr/lib/tmp files.d. If the default parameters are not desired, the file should be copied to /etc/tmp files.d. I don't know what to change because I have never used these things. tmp files.d. Service behavior. /etc/systemd/system. Override. What? Okay, let's ignore those. I'm not going to debug the boot sequence. I know how to use systemd journal d. Journal ctl-r shows the content of journal in reverse chronological order. Great. And then journal ctl-b equals 0 or -1 to show the last boot, or just -b. Less successful boot. And -f to tail. I didn't use core dump ctl yet. Core dumps may use a lot of space, and I can limit the total size of core dumps to 5 gigabytes. Long-running processes. All user processes are killed when a user session is ended, which is okay. I'm not using screen or tmax. Making the LFS system bootable introduction. We need to create a /etc/fs tab. We need to build the kernel. We need to install the bootloader. Okay. So what is this? The FS tab. Let's see the current FS tab. How do we do that? SSH, administrator. Let's copy the IPv4 address. Okay, so there's a /etc/fs tab file. In here we have a, I'm not sure what. I'm not sure what values to use here. But the partitioning scheme is very similar. There is a /boot/EFI and a slash. And they're currently /dev/vdb 2 and 1. But VDB will disappear when we remove the smaller virtual disk, the 35 gigabyte one, where we have installed Kubuntu 25.10. So the slash will become /dev/vda2, and then there's a /dev/vda1, which is /boot/efi. So /dev/vda1 is /boot/efi. Partition type, let's just copy this thing. And then /dev/vda2 is slash, and it's like this. We don't have a swap file yet, but we will. File system, mount point, type, options, dump, and then pass. Okay, this is probably what I want. Again, /dev/vda1, which is this guy, which will become this guy, /boot/efi, whatever is written here, vfat default 02, and then /dev/vdb2 is actually vda2, this guy, and then the rest of this part, /ext4401, and then a swap file. Okay. This is going to be it. For this part. Ctrl+Shift+V. Let's look at it. Begin at CFS tab, file. Yeah, copy paste worked correctly. Next up, we need to build the Linux kernel. 2.5 minutes. Okay, so that's tar Linux 6.16.1, a ton of files. The most challenging task in LFS. So we have the following challenges. We're following LFS, but then we have thrown in some complicated things. We're using UEFI instead of BIOS. We're using GPT GUID partition table. We're using virt.io disk and virt.io network interface card. And we're also using systemd as much as possible. Okay, change into the directory. Make Mr. Proper. No need because it's already clean, but let's do it. Make menu config. Hopefully we don't need to make menu config because there's 1,000 checkboxes there and we have no clue how to configure them. A good starting place for setting up the kernel is to run make dev config. Wow. We're certainly going to mess this one up a number of times until we reach a correct Linux kernel that can actually boot the machine and it's correct. Here goes the first try. So make menu config. So there's multiple options. The simplest one is if by any chance the Linux kernel that you have on the host machine 6.17.0 is similar to the Linux kernel that we use in LFS, which is 6.16.1, which it is. Then a possible thing to do is to actually copy the existing configuration file from the host machine, in this case the virtual machine Ubuntu 25.10, with and overwrite the existing configuration file. If desired, skip kernel configuration by copying the kernel config file.config from the host system towards the directory where we uncompressed the tarball for Linux 6.16.1. Let's actually look at this configuration file. So this is the configuration file on the virtual machine Ubuntu 25.10 /boot/config and then the version of the Linux kernel 6.17.0-8 generic. And the content of the file is totally huge. And we're connected over SSH, so we'll need to copy this file from the SSH server towards the host computer of the virtual machine. So I have copied the file scp, a command line executable that's part of the OpenSSH client application. So with SSH, you connect to the SSH server in interactive mode using a terminal, whereas with SCP, you provide a similar syntax, username at IPv4 address of the SSH server, then colon, full path to the file, and where you want to copy it on the machine where the SSH client runs, which is the current directory. And now we have the configuration file on our computer. And it's absolutely huge. 13,000 lines. And I'm very, very inclined to actually use it. If nothing else works, this is what we're going to do. Okay. Next up. So we cleaned up, and another way of configuring the Linux kernel, other than copying an existing .config file, is to go make alt config, which will build a similar configuration to what's already existing in the current directory, which is the directory where we have extracted the Linux kernel release source code tarball. Okay. But the recommended way by LFS is that you go make devconfig and then change some configurations. Let's see if the way, so there's a new file in here in the current directory. It's called .config. Where is it? Config written to .config ls-la to list hidden files. So this guy. We could also copy this thing to the current computer and compare it. Okay. And then we're going to run make menu config such that we use the TUI text user interface and curses. Hopefully it's reading the already existing configurations and it's displaying those. Your display is too small to run menu config. Let's make the fonts way smaller. Okay, so let's see what it says. Be sure to disable the following features on or the system might not work correctly or boot at all. General setup. Compile the kernel with warnings as error WR. So this needs to be unchecked. CPU task time and stats accounting. Where is that? Why isn't it sorted alphabetically? CPU/task. CPU/task time and stats accounting. So we're at this point. Pressure stall information tracking PSI. What did I do? Exit. Do you wish to save? No. You need to be extremely careful with what you're doing here. So general setup. Oh, see, we did save. No. Compile the kernel with warnings as error uncheck. CPU task time and stats accounting. Pressure stall information tracking. PSI enable. Require boot parameter to ensure pressure stall information tracking disabled. Enable kernel headers through syskernel kheaders. What did I do? Okay, I've pressed the exit button, the second at the bottom. Enable kernel headers through /c/kernel/kheaders.tar.xz. Disabled. Control group support. Where is that? This guy, control group support. Select. Memory controller. Enable. CPU controller cgroup shed. This guy, CPU controller. Group scheduling for shed RR. Disabled by default, correct. Exit. Control group support. Configure standard kernel features. Where is that? Configure standard kernel features. Disabled. Okay, back to general setup. Processor type and features. Build a relocatable kernel. Where is that? This guy. Build a relocatable kernel. It's on by default and cannot be disabled. Randomize the address of the kernel image KASLR. Enabled. General architecture dependent options. General architecture dependent options. Stack protector buffer overflow detection. Stack protector buffer overflow detection turned on. Strong stack protector turned on. Exit. Networking support turned on. Networking support. Networking options. We're at this point. Okay. TCP IP networking. This guy. Enabled by default. The IPv6 protocol. This guy. Device drivers. Generic driver options. Support for U-Event helper. Should be disabled, it is. Maintain a TMPFS file system to mount at /devs, dev tmpfs. Auto mount dev tmpfs at /dev after the kernel mounted the root fs. Correct. Firmware loader. Firmware drivers. I'm not sure why these things are not ordered alphabetically. I don't see advantages. Firmware loader. Vert.io drivers. Wow. Vert.io balloon input. RTC. Interesting selection. Okay, still searching for firmware loader. FPGA. Yeah, I didn't look correctly, so firmware loader is not a child of device drivers. It's a child of generic driver options. So back at the start, generic driver options, firmware loader, firmware loading facility, and enable firmware sysfs fallback mechanism disabled. Exit. Exit firmware drivers. Export DMI identification via sysfs to user space. Mark VGA VBE EFI FB as generic system frame buffer. Okay, that was firmware drivers. Graphics support. Graphics support is under device drivers. This guy, graphics support. Direct rendering manager. Display a user-friendly. Where is it? Message when a kernel panic occurs. Under graphics support. Okay, so something's not okay with the page. Display user-friendly is a child of this guy. Direct rendering manager. So there should be a number of spaces in here, like two extra spaces. Here. It display a user-friendly message when a kernel panic occurs. Enabled. Kmessage panic screen formatter. Panic screen formatter should be kmessage. Wow, how do we do that? Like this. Panic screen formatter should be kmessage. Supported DRM clients. enable legacy FBdev support for your mode setting driver. Drivers for system frame buffers. Drivers for system frame buffers. This simple frame buffer driver. It's interesting that it has marked it as a module. I'm not sure why. Okay, so drivers for system frame buffer simple DRM true. Console display driver support. Where is that? Console display driver support. Maybe in the parent. Console display driver support. Frame buffer console support. Enabled by default. File systems. Where is that? Top level file systems. I notify support for user space. I notify support for user space. Pseudo file systems. TMPFS virtual memory file system support former -m shared memory FS. It's enabled. TMPFS POSIX ACL enabled. Okay. Enable some additional feature if you are building a 64-bit system. If you are using menu config, enable them in the order config PCI first. MSI. So this guy first, and then remap. And at last, this guy, OPIC. Okay, so we need to go this first. That's device drivers, PCI support, message signaled interrupts enabled, device drivers, IOMMU, this guy, IOMMU hardware support, and support for interrupt remapping. And then processor type and features. processor type and features, X2 EPIC. This guy, X2 EPIC, interrupt controller architecture support. Exit. If the partition is in NVMe, I'm not sure if it is, device drivers, NVMe support, and NVMe Express block device. Okay, then we need UEFI support. Let's see how that works. Processor type and features. EFI runtime service support. EFI runtime service support. EFI stub support. Enable the block layer. Partition types. So under enable the block layer partition types. Advanced partitioning selection. EFI GUID partitioning support. Okay. File systems. DOS, FAT, exFAT, NT. Module or enabled. VFAT Windows 95 FS support. Pseudo file systems. EFI variable system. If it's a module, it's okay. Let's enable it though. Native language support, NLS. Code page 437. United States, Canada. NLS ISO 8859-1. Western European languages, Latin 1, enabled. Okay, and then I'm not sure about the virt.io support. Let's see how we find that out. How do we find that out? virt.io sockets. BT virt.io, Bluetooth. Net9p virt.io. virt.io block device. SCSI virt.io. vert.io net. Vert.io console. Sound vert.io. Config vert.io. Where do we find those? Not a pseudo file system. Not a network file system. Networking support. Networking options. I have no clue where to find those. SCSI vert.io. Virtualization. Kernel-based virtual machine KVM support. This is just KVM support for running virtual machines inside LFS, not for running LFS as a virtual machine. Yeah, this is totally not going to go well. Okay, so I have no clue where to enable support for vert.io network interface card and vert.io storage. SCSA, where is SCSI? Device drivers. Lock devices. SATA. Vert.io drivers. PCI driver. Input. RTC. Where are the storage ones? Maybe this is the one. Vert.io network driver. At network device support. It was enabled by default. Okay, so that was network device support under device drivers. But what about the SCSI, this guy, SCSI device support? And there's SCSI vert.io in here. VirtIO SCSI support enabled by default. So hopefully make devconfig has enabled support for these very fundamental drivers, the VirtIO storage for the virtual disk and for VirtIO for the network interface card. Okay, so this should be it. We need to save the configuration. We have run make devconfig that just generated a .config file, and then we're customizing that .config file using make menu config. So go exit, and then we're at the top level, and we go save the correct file name .config, exit. Let's actually exit, re-enter, and check just one setting, make sure that nothing was lost. Let's go for the, what did we actually change? This guy, DRM panic. So graphics support, under device drivers. Graphics support, and DRM X3, and display a user-friendly message when a kernel panic occurs. Looks okay. Exit everything. Phew. Compile the kernel and modules. Make. If using kernel modules, module configuration in /etc/modprobe.d may be required. If using kernel modules. I'm using 2 kernel modules. I have tried to make everything, every Linux kernel configuration that was mandatory in here, like this. So asterisk, not uppercase M, which means including it in the Linux kernel binary file, not a separate binary file for the Linux kernel module. But indeed, there were 2, at the very last, there were 2 features of the Linux kernel that were of type uppercase M, not of type asterisk. Okay, so this might take a number of minutes compiling the kernel, so we'll be back. Make modules install. After the kernel compilation is complete, additional steps are required. Some files need to be copied to /boot. If you have decided to use a separate /boot, nope. The files copied below should go there. Create an entry for /boot in /etc/fs tab. And then inside the root mount /boot, no need. The path to the kernel image may vary depending on the platform being used. What are you talking about? Okay, I'm not sure what that is. So the busy image now became /boot/VM Linux and then something with LFS and systemd. system map, symbol file for the kernel, function entry points of every function in kernel API, addresses of data structures, running kernel, investigate kernel problems. Okay, the .config file, documentation, the kernel source directory are not owned by root. The files have the user and group IDs of whatever they were on the packager's computer. Sure what that means. Okay, so in here it says that the kernel that I have just created might not be perfect. We might not be able to boot the LFS system. The system might boot, but then some obvious things might not work. And in that case, it's easy to just keep the directory /sources/linux -6.16.1 available. We're not ever going to delete this directory. We're not going to run make Mr. Proper. We're just going to edit a bit the configuration file, probably using menu config, and then do an incremental build. So the .o object files are being kept. We're doing an incremental build that's going to be fast, and then the resulting kernel and kernel modules will be very similar to what we had before. So we're incrementally just improving the kernel. Or also when you're using BLFS, so after you finish running the LFS Linux from Scratch book, you will have some packages installed, but then you might choose to install additional packages from the other book, from BLFS Beyond Linux from Scratch, such as a X server, a desktop environment. Maybe you want to install, I don't know, VirtualBox or other software that does contain a kernel module or does need a kernel module or kernel support in kernel mode. And you might be forced at that point, while installing your BLFS package, to change a bit the existing Linux kernel. So again, in this case, you would go to /sources/linux minus then the version, edit a bit the configuration file, and then do an incremental build, and then deploy the new kernel image and modules and configuration files and everything. All of the things that we just did right now, plus the bootloader part. So it says that we should run this thing. On the Linux directory. Recursive, okay. Let's do that. Okay, we need to make sure that the user with user ID 0 and the group Linux user group with group ID 0, GID 0, is the owner of the directory, because we're now inside hroot inside Ubuntu 25.10, but then at some point we'll be inside another Linux operating system, LFS, Linux from Scratch, and there the root user might be different, or might have a different alias, something like that. Okay, so now we're not running make Mr. Proper. If we need to update a bit the kernel, we'll not upgrade the GCC. we're not going to have a /usr/src/linux directory. Configuring Linux module load order. Most of the time Linux modules are loaded automatically, but sometimes you need some additional help. Okay, let's see. This file needs to be created so that if the USB drivers EHCI, HCDO, HCI, HCD, and UHCI, HCD have been built as modules, they will be loaded in the correct order. Okay, seems fair. Contents of Linux, there's the image and the .config file and the symbol table, symbol map. GRUB. In case we're using UEFI, we should ignore this chapter. Almost. Okay. Still learn the syntax of grub.cfg and the method to specify a partition in the file from this page. Okay, let's see what it does. So let's install GRUB. We have already configured, built, and installed GRUB, the grub, the bootloader, but we did not yet configure it. We need to tell it where that we're using UEFI, where is the FEVARS file system, that we want to write some EFI portable executable binaries there, and how the boot menu should look like. So it says that if you're using UEFI, you should go to the BLFS page about UEFI plus GRUB. Hopefully we're not using secure boot. If the virtual machine uses secure boot, then we'll disable it from the BIOS screen. We did enable the kernel configuration for UEFI support. We're not creating an emergency boot disk. This talks about creating a USB disk that has a GRUB inside UEFI, and that's not configured. That's, you only get the bootloader GRUB without any knowledge that there's an LFS file system, there's a Linux kernel, etc. Okay, so we need to find the EFI system partition. We're inside the chroot. Mount only knows about /dev/vdb, which is mounted on /. Doesn't know that in fact we're inside /mnt/lfs, which is /dev/vdb too. But it doesn't know about /dev/vdb1, which is the special EFI system partition ESP at 32. Okay, lsblk, which is this guy, vdb1, EFI system. Let's do what it says in here. So fdisk, and then what we should do, we should list dev/vdb. Okay, so the first one, /dev/vdb1, is the EFI system. We didn't create a mount point. So what we want, we're inside the root. We don't have a /boot/EFI directory there. We don't have /dev/vdb1 mounted there as vfat. We don't even have we have a partition of type UEFI system partition, but it's not formatted as vfat yet, if I remember correctly. So probably this huge command line does everything. Makes sure that there's a directory /boot/EFI, looks at the partition /dev/vdb1, formats it. No, it doesn't format it. So hopefully it's formatted. What can I say? Yeah, we'll see if this thing works, but make sure we're not using SDA1. So that's VDB1 /dev/vdb1, and the rest maybe works. Okay, let's see if we can list what's happening there. Yeah, hopefully we have formatted. I don't actually remember when I have run the incantation makefs.fat32 to create to format the partition. I remember when I used fdisk to create the partition at the correct start point with the correct size 300 megabyte and the correct type EFI system partition ESP. Okay, if you want to mount the ESP automatically during system boot, yeah, we already did that. So we have it in the first position /dev/vda1 /boot/EFI vfat defaults 02. I'm not sure what these things do, but hopefully it's the exact same thing. And yes, I have added this one myself. So if I did not, if I had respected the instructions from Linux from Scratch book correctly, then this command line would be correct, because it appends with greater than to /etc/fstab. Okay, so in here in /boot/EFI, we need to write these files with uppercase file name and directory. Boot x64.efi. I'm not sure what this ---- removable thing, command line parameter to grub install is. Okay, let's try our luck. Grub install target x8664EFI ---- removable. Grub install also detects that the current system is booted in UEFI mode. So because grub install needs to switch between booting in UEFI mode, which means EFI portable executable style binary files in the EFI vars fs in /boot/EFI /boot x64.efi versus booting in BIOS mode, which means installing to the MBR master boot record of the current disk a small bootloader instruction. And by specifying x86-64-EFI, we also specify that we don't want the BIOS boot, the legacy where it's writing to the MBR. Okay, let's actually see this thing. So ls/boot/EFI, there should be a EFI directory with all uppercase. There should be a boot directory there. And there should be at least one EFI file, boot x64.efi. Okay, so this is a GRUB installation that's running as part of UEFI. UEFI is like a operating system. It can load executables from files with extension EFI if there's a file system of type vfat on FAT32 on the disk that's GPT GUID partition table and has the special GUID type for the partition of type EFI partition table. Okay, then it says that we should mount /c/firmware/EFI/EFI vars. Let's see if that thing exists. ls/sys firmware EFI vars. It's probably not mounted. Okay, now it's mounted. System is booted with UEFI and systemd. EFI vars is mounted at the correct place in /sys, but we're not at the same place in /sys because we're not in the host operating system. We're not in Kubuntu 25.10. We're inside a root that starts from /mnt/lfs. And in there, in /mnt/lfs, there should be a sys directory and there should be a sysfs mounted there, and then the EFI vars file system should be mounted at /mnt/lfs/c/firmware/EFI/EFI vars. Setting up the configuration. Okay, and there will also be a file grubx64.efi. Okay, and the identifier that we're using is LFS all uppercase. So we're actually targeting to create this file /boot/EFI and then all uppercase EFI LFS and then lowercase grubx64.efi. /boot/grub. Okay, so it says that we should install the bootloader with ID LFS and then recheck. Let's check that. EFI boot manager not found. So we actually need EFI boot manager that we did not install. Yeah, the instructions for building GRUB with UEFI said that EFI boot manager is optional, but it's not. grub install error, EFI boot manager not found. So let's see how hard it is to build that thing. We have grub. We're not using the free type unifont use LVM, but it's recommended EFI boot manager runtime. So let's see that. Provides tools and libraries to manipulate EFI variables. Okay. We go to the sources directory and see if there's EFI boot manager in here. It should not be. At letter E, there's just E2FS elf-utils expect. So we need this file. We don't have wget there. And it requires fevar and popt. Wow, how do we do that? We don't have curl, we don't have networking. We don't have wget. Let's see if we can, from inside the virtual machine, do this download. Maybe the chroot automatically just sees the file. How do we do that? This guy. Okay, and the directory is mnt lfs sources, and let's download things there. wget this. I should be the user root. cd/mnt lfs sources wget and then this thing. Okay, and required dependencies. fevar doesn't depend on anything, hopefully. And popt doesn't depend on anything. That's great. Okay, so fevar probably comes first. Okay, let's see if we see the files now. ls-la lsefi. They're in here. Okay, so again, in order to install, in order to build grub with UEFI support, we don't need EFI boot manager, but in order to install grub for UEFI, we need EFI boot manager. EFI boot manager depends on fevar and popt. Let's start with popt. Parse command line options. Wow. cd popt and configure and make. We're not using Doxygen. We don't want the API documentation. We're not after running the test suite. Just make install. We did not build the API documentation. We're the user root. just one file, libpopt.so. Sounds okay. We finished with popt. Let's clean up. Okay, next up, f-var. f-var. Okay, optional man doc. We don't need a man page. Enable docs 0. Copy. As the user root, we make install. To avoid a hard dependency on mandoc, we used enable docs 0, but it causes all man pages skipped from the installation, even though most of them actually do not need mandoc. We can install some man pages that don't need mandoc. Okay. f-var executable. Next up, EFI boot manager. We have already downloaded, so unzip it. FE boot manager. Build FE boot manager. And install it. Okay, so what does EFI dir LFS mean? Is that it will use /boot/EFI and then EFI all uppercase, which means that /boot/EFI must be mounted, which it is. This thing. And then we specify the name of the file. Okay. At this point, we finished with FE boot manager. Okay. And we can go back to where we did not succeed, which is GRUB with UEFI. We have run this thing to put the file boot x64, but now we need to put the other file, the grub x64.efi. This guy. Installation finished, no error reported. So I have the correct standard output, standard error. Let's recheck using EFI boot manager. Boot current 003, timeout 0 seconds, boot order, UI up, LFS, UEFI MISC device, and Kubuntu. Wow. We can see that the manual was written with the host operating system being Arch Linux. Okay. Note that 005 is the first in boot order. Where is that? In here. So it's going to boot 001, which is LFS. Correct. So we can eventually even keep the two virtual hard disks of the virtual machine. But then I'm not sure if /dev/vda1 will work, because we have it in two places in the Linux kernel command line and in the /se/fs tab. So at least should be the second one. But we'll see. Generate /boot/grub/grub.cfg. Okay, so let's see what we need to change in here. Defaults, timeout, GPT, GUID partition table, ext4. First start is correct. The second partition for the root, correct? We don't have this font, but it's guarded with a if /dev/ what is this? VDA1. VDA2, because VDA1 is the /boot/EFI. Okay, so let's check again. ext4, first disk, second partition, correct. First disk, second partition, correct. But virtio type, not SCSI, SATA. This is it. Okay. Let's see that this file actually exists. The /boot1. So VM Linux 6.16.1 LFS minus 12.4. So it's actually wrong. So this is the correct name. Okay. So this is the name of file. VM Linux ends with -systemd. Boot grub and grub-cfg. Okay. Ends with -systemd, the Linux kernel image name. VDA2, correct. Sounds okay. EFI based video support, UGA and GOP. We're not going to dual boot. And that should be it. So it says that we should skip the instructions, which we did. We're not creating a rescue disk. GRUB naming conventions. For the first disk, that's HD0. For the first partition, that's 1, not 0. Okay, this talks about the BIOS style boot, not UEFI, where you install GRUB at the start of the virtual disk. Okay, what else is there to say? Instead of using device names, so /dev. You might use UUID, part UID, or the /etc/fs tab, and that's totally a good idea. But we're going to risk everything. Okay, this is the end. Well done. The new Linux from scratch system installed, including the Linux kernel, the bootloader, EFI system, everything. Okay. We should have a file /etc/lfs -release. /etc/lsb -release. The LSB book tries to respect a bit the 3 standards. For Linux, the FHS, File System Hierarchy Standard, LSB Linux Standard Base, and the more general Unix style standard POSIX. Some aspects of these standards are respected in the sense that, for instance, there will be a file /usl/bin/ls, which is needed by POSIX. There will be a file /etc/lsb -release, which is needed by LSB Linux Standard Base. The directory structure will look in a certain way because of the FHS standard. For instance, we configured some packages that we have installed to respect /etc for the root of the configuration files, such as Vim. Okay. So there's LSB release, there's LFS release, and there's OS release. Okay. We're creating a more complete /etc/os release file. Be sure to customize the fields distrib codename and version codename. Where is that? To make the system uniquely yours. Okay, let's do that. Let's make it your name here. Okay, so let's list the 3 files. /etc/os -release looks okay. LFS release, and the third one, LSB release. Okay. Get counted LFS counter. Rebooting the system. Now that all software has been installed, it's time to reboot. Install any firmware needed if the kernel driver for your hardware requires some firmware functions to function properly. Hopefully no need for that. A password is set for the root user. We did that. How do we check that? Passwd, the login. Please enter the password for the user root. Yeah, we did it with a minimum of 5 characters message. Okay. Cat /etc/fs tab. It's okay if we're going to remove the first smaller virtual hard disk. /sc/hosts. Okay, doesn't really say much. Input rc, I don't know what content this file should have, but I know we did create it. Profile was something about the Linux. Where is it? Linux type of terminal, this guy. Okay, resolve conf, we don't have it, and vim rc was configured for support for legacy VI. Now that we have said that, let's move to booting. Exit the chroot. We're not in the chroot any longer. We're the user root on the host file system, Kubuntu 25.10. Make sure the environment variable LFS is set. It should be. We never exited the system with this environment. We just entered from one environment to another, and now we have exited the innermost environment, the root user. Okay. So this was a wrong paste, and I pressed Ctrl+C to not execute whatever this thing was. So if you mounted a ton of things, if multiple partitions were created, /home, nope. And then we need to umount /mnt/lfs. Says that /mnt/lfs/sys is busy. So let's umount that again. It's a virtual file system. We probably need to remove this guy. Okay, that was it. So the EFI vars file system was mounted as /mnt/lfs/c/firmware/EFI/FE vars inside the chroot. We've unmounted that, and now we could unmount /mnt/lfs/sys, and now we can unmount the /mnt/lfs. Why can't we? Okay, that's it. Now reboot the system, assuming the grub bootloader was set up correctly. There will be a boot menu. We need to select LFS systemd. It's selected correctly. Okay, so virtual machine, shut down. Let's see if we'll shut down correctly. We don't have a shutdown. Okay, we're not connected over SSH. The computer is shutting down. We're going to go at the settings. We want to at least make sure that this file is not part of the virtual machine, even if we don't delete the backing lfs.qcov file. So let's remove this thing, but not delete the associate storage files. Now the first and only Vert.io disk is the one that's 200 gigabytes in size. It's named LFS-1 QCOW2. Okay. And boot order should be Vert.io disk 1. And that's it. Nothing else to configure. Just start. Let's see what it says. So it says that it's trying to boot in secure boot mode, and this system that we have installed doesn't support secure boot. So let's enter BIOS. I have pressed the enter key. Device manager, secure boot configuration, and attempt secure boot at next reboot. I'm pressing the space key. I need to reboot, F10 to save. Doesn't work. F10 to save. Y. Escape. And reset. Okay, we see GRUB. It was installed correctly in the correct partition. The partition started at the correct place, was of correct type EFI system boot. There were the correct EFI files in there, at least 2 files. And now let's see if I have configured the Linux kernel command line and the Linux kernel location correctly in the GRUB configuration. I can see systemd. I can see a kernel with the correct version. I can see that the boot has finished. I can log in into VT1, username root, password, and I'm in. Okay, let's see where we are right now. Mount grep dev. So we have /dev/vda1 on /ext4, correct. We have /dev/vda2 /boot/EFI of type vfat, correct. We can exit the virtual machine. And what could we do next? So everything was just perfect until this moment. We managed to build the Linux kernel correctly, the bootloader, the complications around EFI. Everything has just magically worked from the first try, from what I see in here. What could we even test? df3 du minus hs dot slash 6 gigabytes pwd umi w lsblk cat/etc/fs tab. We don't have a swap yet, and this is a priority. Let's actually create a swap file. I have searched on Google Arch Wiki Swap. I'm going to the Arch Linux Wiki, the swap page. I'm not going to use a swap partition. I'm going to use a swap file. I'm using ext4. The swap file is going to be named /swap file. 4 gigabytes sounds okay. I cannot copy paste because I don't have a SSH server, so I need to write all of these things by hand. Make swap minus uppercase U, clear, minus size, for G, minus file, slash swap file, make swap, minus U, clear, minus size, for G, file, swap file, swap on, slash swap file. Okay, edit the FS tab, and here is the hard part because I don't know how to use Vim. vi slash etc slash fs tab. I need to enter insert mode. Slash swap file, I have uncommented the line. Swap defaults 0. Okay, I need to write escape WQ exclamation mark cat slash etc slash fs tab. Looks okay. We're not going to use a swap unit. We're not going to remove the swap file. And that's it, no swap encryption. At this moment, I want to reboot. Okay. Maybe the name of the bootloader item is not great. That's probably specified in slash boot. Where was it? So the menu entry is wrong, but I don't know how to fix this thing. Let's see. And that's it. The configuration file will be just read. Traditionally in Ubuntu, when I needed to edit the command line, I have used the defaults directory, and that required that I run update Ubuntu each time I have edited the configuration file. But this time, it seems that everything just works. No need, you can just straight edit a group configuration file and then just reboot and it will work okay. Okay, let's insert mode. And menu entry, GNU Linux, Linux 6.16.1 minus LFS minus 20.4 minus systemd. Okay, escape, WQ exclamation point. Let's reboot. And now the correct name for the Linux kernel is available. Default timeout 5 seconds is huge. Let's actually improve that also. Oh, something's wrong. Control L. Okay. And the default was 5 seconds, and it's way too huge. Insert, so this thing should be 1. Escape, Q exclamation point, go. Okay. Next up, networking. IP exists, IPA exists, IPA works. IPA returns the correct thing, which is an IPv4 address with the correct IP address ending with 193. It's 192, not 193. Okay. Let's see if we can ping the DHCP server gateway. Let's see what's happening. Let's see if I can ping localhost. Let's see if I can ping the string localhost. Let's see if I can ping the gateway. Ping 192.68.122.1. Okay. Let's see if I can ping websites. Wow, I have networking. wget, nope. Curl, nope. Why would I not install wget or curl? What was the reasoning? That was strange. What other software could I use to download a tarball source code, tarball for instance for the text user interface, text editor nano, and then build and install it? Okay, and the book actually is going to end. Work from the LFS host in chroot. Work remotely via SSH. We did not install OpenSSH server. Really bad idea. So we succeeded in completing the LFS book, but we failed because the LFS book should have said, don't reboot, you don't have a HTTPS client yet. You don't have wget, you don't have curl. How are you going to continue from here on? For instance, to install the OpenSSH server, you will need to download the source code tarball for the OpenSSH server. Let's see what we have in sources. So wget, nope. Curl, nope. Links, nope. OpenSSH server, nope. So how can we download things? It's extremely strange that networking works perfectly with systemd minus networkd, but I don't know how to download things. Maybe using Perl or Python. So I couldn't really use this LFS virtual machine because I can't really copy paste text. So that will require at least open SSH server, maybe also a web browser. So a minimum minimorum that we would require right now is to have either an easy way to download files, for instance using Perl or Python, or to just download the source code tarball for wget and install that. And wget is available not in LFS but in BLFS, Beyond Linux from Scratch. This is the URL, and how I did it in the virtual machine. I have entered Python, so that's Python 3. It's an executable that starts the Python 3 REPL, read, evaluate, print loop. And in there I have searched on Google Python one-liner that downloads a file. Takes me to the Stack Overflow response, and I'm using this response. So Python 3, as you can see in here. So no, I have entered Python, and then from there I have pasted this. So from URL lib.request.import URL retrieve. And then a second line URL I have pressed enter instead of this semicolon, and then on the second line I wrote this thing. So URL retrieve, and then the URL, and then the name of the local file. I made sure that I'm in the /sources directory first. So the invocation is like this: cd space /sources, enter Python 3, enter, from URL lib.request import URL retrieve, enter, and then URL retrieve, and then as parameter a working URL and a local file name. And the URL did not work because it was HTTPS. So the default download URL for wget uses the HTTPS protocol, and that created the certificate verify failed Python error. This might be because maybe I don't have the HTTPS support installed inside LFS. I don't have CA certificates, the root certificate authorities. Maybe Python is not instructed to use the certificate authority, the root certificate authorities that are installed on the current Linux operating system in LFS. And the workaround was to replace the HTTPS protocol to HTTP. So instead of using https://ftp.gnu.org, I'm using ftp://ftp.gnu.org, etc. It didn't provide any error. I can see that it requests the file name, so that's advantageous. I don't really want to write to standard output using Python this in the content of the URL, but instead I want to save locally the file, and the URL retrieve seems to do that because it requires the name of the local file in the current directory that the downloaded file will be written to. And from another VT, send key Ctrl-Alt-F2, I can see that the size of the file /sources/wget -version.tar.gzip is 5 megabytes. So hopefully this file is okay. So we can run the recipe from BLFS for wget. So let's do that. It says that W depends on libpsl and on makeCA. And makeCA depends on P11 kit and NSS and. So let's try first to have either a one-liner written in Perl, a Python script that knows how to download files over HTTP, or we want wget without SSL support, without makeCA optional. Eventually we'll rebuild wget after we get the dependencies. So let's try first without any of these dependencies. So cd/sources. Okay. So again, wget, we have downloaded the tarball. We don't have libpsl, we don't have makeCA, we do have OpenSSL, we don't have GNU-TLS, HTTP daemon, IOSocket, libidn, libproxy. We might have PCR-E2, no we don't, and valgrind. Enable libproxy. I'm not going to use it. I'm not going to use the valgrind tests. Okay, so let's see if we have tar. Hopefully we do. Wget, change into the wget directory. And I need to issue all of these things by hand, which is really, really problematic. /configure -- prefix equals /usr. So I should not have rebooted into the new operating system before I installed at least, I know, 20 packages from BLFS. I need HTTPS support, so that's CA. I need wget, maybe even curl. I need the entire OpenSSH server because I don't want to self-dictate. I don't want to read text and then write it with my hand. I actually want to copy-paste, which doesn't work yet. So /configure -- prefix. slash usr minus sysconf dir equals slash etsy minus with minus ssl equals open ssl. So let's read configure prefix slash usr sysconf dir slash etsy with ssl open ssl go. Okay, so that was the configure step, then the make step, and then we're going to skip the checks and make install. Make install. Okay. And this is it. Which wget. I don't have which yet. Wow. Okay. I'm not sure if I know how to download HTTPS files yet using wget, but maybe wget has a command line parameter to ignore all HTTPS errors. That would be really great. So let's actually remove the temporary directory. Okay. And try to download something. Let's move away. Let's see what's needed for OpenSSH server. So I went like this. Make CA is part of a group for BLFS called security. We go up. And one of the packages in here is OpenSSH server, which I'm going to expect it has a ton of dependencies. So optional. That would be way too easy, way too nice to not have any other additional dependencies. Okay, so where am I? Source is correct, wget, and then I need to self-dictate this huge monstrosity of a URL, HTTP. I'm trying with HTTP protocol first, FTP openbsd.org slash public openbsd OpenSSH portable OpenSSH minus 10.0 p1.tar.gz. So wget http //ftp openbsd.org /pub openbsd OpenSSH portable OpenSSH 10.0 p1 tar.gzip. And what do you know? It actually worked. Hopefully, if it just works, even if it's not configured perfectly, that would give us the possibility of copy pasting between the web browser and the LFS virtual machine, which is going to be a huge advantage over me self-dictating myself long URLs. Okay, so tar xvf OpenSSH, cd OpenSSH, and let's see the instructions. Wow. Install -v-g, huge possibilities of getting something wrong by me writing everything by hand without copy paste. varlib sshd. So install -v-g sys -m700 -d /var/lib/sshd. group add minus G50 SSHD. This is probably the group ID GUID 50. A new Linux local user group is created SSHD. And then we're creating the user. SSHD revsep. What is that? We're missing all of these dependencies. We don't even have PAM. This is probably the user ID, UID50. User add minus C SSHD revsep minus D slash var lib SSHD minus G SSHD minus S slash bin slash force minus U50 SSHD. Just warning. Great. And then configure. The bash prompt is really, really bad. It doesn't say the current directory. Configure. Fix. And then we're going to run make. We're not going to run the tests and make install. Looks okay. Make. Okay, so that was successful. Make install. And then this huge thing. Okay, so this was about documentation and man page. And this is the executable /usr /bin /ssh minus copy minus ID. Okay, what I'm curious right now, if I needed to specify some special command line parameter for the configure step if you want to use systemd, and I want to use systemd. I want the systemd.service files for the SSH server. Configuring SSH. So this configuration is for hardening the security of the SSH server, but just for now I don't need this. I'm not even sure that there's another Linux user account on the LFS computer except the user root. So I do want to connect interactively using the user root, using password. So all of this hardening is something to do in the future for me, not now. And I didn't install PAM yet. And to start the SSH service at start using systemd, there's this package blfr systemd units. Okay, so these are the instructions. I have finished installing the SSH server, but then I'm going to need to start the SSH server. Probably it's easy via the command line. But if we can, I'm going to try to actually install the SSHD systemd units. For that, I want to download this tarball with a huge name, so I'm not going to do that. And then extract it, change into that, and issue the command line make space and install minus SSHD. I'll need to decide immediately if I want to either start the SSH server by hand from the command line, or if I want to write all of these things by hand. And I want to write all of these things by hand. Okay. So pwd cd wget. I'm not even sure HTTPS works. So let's again try with HTTP, not HTTPS. Okay, so even though I specified HTTP protocol, it still try to connect via HTTPS because there's HTTP 301 moved permanently. And then it complained that the HTTPS certificate cannot be checked because I don't have the certificate authorities, the root certificates installed on the current computer. But it suggests that I use this command line parameter, no check certificate. So I'm going to run the same command line again. Unfortunately, control left and control right don't work. The commands, the key combinations to jump one word to the left or to the right. And I don't know the GNU read line, command line, the command, the keyboard combinations to jump one word to the left or to the right. But I can find those out. So wget -press no check certificate and then the URL. ls. The name is blfs systemd units. So tar -xvf blfs systemd units. cd in there. pwd who am I. And then inside there's a ton of systemd units. We're only interested in the one for the SSH server, and we should just run one command line, which is make space install minus the name, and that's sshd. So make install minus sshd. And this should be it. It already created the symlink, but we're still going to check. So system ctl status sshd. It's both enabled and started. That's strange. Yeah, we're going to restart the computer just in case. Okay, and let's see if we can just connect. The IPv4 address is correct. Control L to clean everything up. SSH, Linux username root, at IPv4 address ending in 193. Yes. Password. Permission denied. Okay. So the default configuration file for the OpenSSH server does deny connecting with the user root and a password. So let's fix that issue. Log in as the user root, password, and go to the configuration directory, add CSSH, and the configuration file should be sshd config, the final file there. Let's look at it using the paginator less sshd and port 22 and permit root login prohibit password, which is a problem for us. Permit empty password, password authentication. So we need to change permit root login to be, I don't know, yes. Let's make a copy, backup copy. Okay, and we can edit the file now. Let's see that everything's okay. Control R works for searching in the history. Permit root login listing. So insert mode. Let's write it again. Permit root login. Probably yes. Let's see what the value for true is. No and yes. Okay, escape, WQ, exclamation mark, reboot. Let's see that the timeout is 1. And it is in GRUB. And let's connect again. And success! Now we can just copy paste from any web browser towards the LFS virtual machine. Okay, so we have SSH, we have systemd, we have the systemd unit such that the SSH server works. Great. What do we need next? The very first thing that we need is the CA root certificate authorities. So back to wget, this guy, make CA, that depends on P11 kit, which needs libtassen, NSS, wow, there's a ton of dependencies there. So libtassen is a C library for ASN1. Okay, it only depends on documentation and Valgrind, so let's do it. /sources with the user root. I need to edit the ps1 bash prompt environment variable. So let's see this. wget, no check certificate, control K, it does work. Control Shift V does work. Okay, let's extract it. tar -xvf libd cd libta configure and make. Wow, what a luxury to just be able to copy paste things without writing very complicated characters on the keyboard and long incantations from with my own hands. Okay, that was that. I'm the user root. Make install. I don't have enable GTK doc. You can install the API documentation using this. I didn't use any man pages, HTML documentation, etc. for anything yet inside the LFS system. So we have libtassen and we need P11 kit. Circular dependencies on make CA. Okay, so change to the parent directory rm-rf libt. Okay, the wget thing. Control right arrow does work. Control K. Copy link, Control Shift V. tar -xvf p11 cdp11 and this prepare thing. We don't have make CA yet. So this was creating a build directory, the equivalent of the configure step, the equivalent of the make step. We're not going to run the tests, and then make install. Okay, make install. libnss transparently to make the system CAs available to NSS aware applications. Okay, so we should do that. But we still don't have the CA certificates yet. We have update CA certificates, but we don't have make -CA. AP11 key, that was that. So make CA depends on P11 kit, did that. We built libtazen. Let's see NSS, how complicated is it? Requires a patch, a PR. Netscape portable runtime. Yeah, I'm actually going to do this. Copy link. So we're inside the P11 kit. So change to home directory twice. rm-rf p11. Okay. wget, no check certificate, Control K, Control Shift V, nspr, tar, xvf, nspr, and build it. APR, the Apache Portable Runtime, NSPR, the Netscape Portable Runtime are good basic blocks needed by many other packages. pwd, cd, and nspr, Control Shift V. Hopefully I didn't cause any problems by running this in the wrong directory, because it uses end. So this one, the first one, failed to change into this directory, so nothing else was run. So this is actually a bug fix when you see end. Okay, make install. This is it. Exit from here. Okay, remove nspr. We did that. NSS requires nspr, doesn't really require SQLite and P11 kit. We did P11 kit. Let's see SQLite, how complicated it is. Depends on libedit. Well, okay, so we want NSS and the patch. So pwd wget Ctrl K the URL, the patch, Ctrl Shift V, extract NSS -3 cd NSS -3 pwd. I have downloaded the patch. An internet connection is needed for tests. We're not going to run the tests. Apply the patch and then build. This is also a bug fix, so says NSS use system SQLite if SQLite 3.h exists, because it says that SQLite is recommended but not mandatory for NSS. So we have built NSS without having built SQLite first. We're not going to run the tests. And then we're going to install. Okay, so compiling worked. We're not running the tests. We're installing. Wow, imagine having to write all of these characters by hand without copy paste. That would be something. Okay, we should do this symlink. And then we're at make CA. So make CA depends on P11 kit, libtezen, NSS. Okay, right click, copy. wget, Ctrl K, Ctrl Shift V. What am I doing? Yeah, the fact that the current directory is not in the bash prompt, that's a big problem. Okay, so we need to get out of this directory back to /sources, then remove NSS -3 directory, then copy this thing, Ctrl K, Ctrl Shift V, and hopefully it worked. Extract. Okay, we're in the correct directory with make CA. Install the make CA script in the correct location. The package is installed. Okay, so we don't actually need make -ca. We need the root certificate authority certificates, whatever the certificates that sign the other HTTPS certificates. pwd Ctrl+Shift+V set data.txt. Downloading set data.txt. And now it's adding the important root certificate authorities. Done. Java certificates JKS. You should periodically update the store with the above command make ca -g. A timer is installed as /usr/lib/systemd/system/update-pki.timer. Execute the following to enable the timer. Okay. Configuring make ca. Mozilla release branch contains cert data.txt. Additional CA certificates. The etc SSL local directory is available to add additional CA certificates. This directory is also used if you need to override the trust values or otherwise need to create an OpenSSL trusted certificate manually. I know, I'm going to ignore everything below because it says that this is it. Technically, this package is installed. We're running the makeca program. For most users, no additional configuration is necessary. Yeah, I'll remember that there's some additional nodes in this package for make -ca. There's ca cert root, there's ca cert class 3. Disabled make-believe ca root. Creating my own certificate authority, root certificate authority. And we certainly want to make Python work correctly. Using certify PIP3. We have P1, P11 -kit installed, makeca installed. And we want PIP3 to use the system certificates. To use the system certificates, you should set PIP standalone cert to point. Okay, so in here it says that Python has its own idea of how the root certificates are, but then the system has another list of root certificate authorities. And we want to tell Python 3 each of the time, hey, ignore your personal store of root certificate authorities and to respect the root certificate authority store that's on the operating system itself. That's being done by creating an environment variable _pip _standalone cert. And we might set this environment variable when we want, or we could use /etc/profile.d, which I'm going to create. I'm not sure if this file is going to be ever used, /etc/profile.d/python-certs.sh. But if it's not, then I can easily source it. I can easily go source /etc/profile.d/python-certs.sh to set this environment variable, if I can remember. If I'm going to run Python again and try to download and download will fail, I'm going to remember that there's a bash file that I can source, or an environment variable. Okay, so that's it. Next up, I should exit from here, go to the parent directory, remove the temporary directory, make -ca, and remove the file make ca, and then try wget without any additional parameters using an HTTPS URL. And it should say that the HTTPS security certificates, cryptography is okay. And it worked. Great. So now we can connect to the Linux from scratch virtual machine using the SSH server. We have systemd, we have the SHD systemd unit, we have wget, we have the correct HTTPS cryptography. Next up, what would be next? MC, Emacs, Nano, Firefox, a web browser. So this is the end of the LFS book. There's a glossary, there's people, and one of the last words, it says that you would want make ca, I did, you want p11 kit, I did, you want libtasn, I did, you want wget, I did. GPM is the mouse driver probably, and I don't need it because I'm connected over SSH. And then I want one of the web browsers, links or links. Let's see which is which. Which was better than the other. I'll probably get both. Yeah, but you don't really need a web browser because then you also need a mouse driver, and I'm not sure if that works over SSH, and why would you have a web browser? I usually have used the text user interface command line web browsers just to download files and multiple files in the same HTTP directory, or maybe to download files over FTP. So the way I did it, if I had a huge link like this and it was the FTP protocol, I would go the command line, which is links, links space, and then FTP colon, and then the top of the URL, the first part, the hostname. And then from there, I would navigate using the web browser towards download, and then I would find this thing and I would download it. So a shortcut of when copy paste doesn't work, instead of going wget and then this huge path, I would go links and then FTP and then // links.twibright.com and navigate from there for very complicated URLs. So actually I don't need a web browser, and it also requires SVGA, lib, all sorts of old things. GPM extremely old for me. I wish to never use GPM again. I have used it in the more than 20 years ago. Okay, so we'll not do this. A very basic library, GNU-TLS, probably libarchive. What else could you do with LFS once that I got at this point? Probably start installing the graphical user interface MC. Let's see if we have Midnight Commander, and then we'll stop. Okay, so let's go to the homepage, linuxfromscratch.org. We did the entire LFS book, Linux from Scratch. And now we're trying to look at the BLFS and see what this is all about. Download. And we want, there's two versions. There's stable without systemd and stable with systemd. And we want the single page HTML. Okay. And let's see what it does in here. So it starts from LFS and then it adds additional things in there. Console fonts. We did make CA. IP tables if you want NAT, network address translation. And IP forwarding. We did NSS, we did OpenSSH server. Shadow was part of LFS. Yeah, we should do sudo. And what else? We should do nano. Emacs, maybe it's an advanced topic. And then we have MC Midnight Commander. And then from there on, there's only two directions you could go. Either prepare a server computer, so not ever install the graphical user interface, Xserver, Wayland, compositors, KD, Plasma, etc. And that means install one of the HTTP servers, such as Apache, or install another type of server, a email server, a FTP server, etc. Or go towards the graphical user interface. Let's see what's available in the graphical user interface. QPDF. So there's screen. There's Firefox, Falcon, SeaMonkey, 3 web browsers. There's the entire LibreOffice suite. Wow. There's LXQT desktop, XFCE desktop, GNOME desktop, KDE desktop. But KDE desktop will require network manager and disabling systemd-networkd. There's Qt Web Engine. So building the entire Qt Web Engine, the entire KDE Plasma desktop, that would take some hours. Okay, so I'll just do sudo and MC and then I will stop. Sudo. Where is it? Okay, let's download sudo. wget Ctrl-Shift-V *xvf sudo cd sudo depends on PAM, which I don't have. So maybe PAM would be the next thing to do. Okay. pwd configure and make. Then make install. And after that, I want the Midnight Commander text user interface TUI file monitor, file manager. So this type of HTML, no chunks, just one single file is advantageous because you can easily search in the entire book, and then copy pasting will work probably way better than from the PDF version. Okay, so that built. Now we can make install. Okay, there's a configuration file /etc/sudoers. Let's see if the file exists yet. Let's see what it does. So it's the way I remember it. What I do in here is I uncomment this line, which says that the Linux users which are member of the Linux user group will, if they specify their own password, can become the user root. So I like the default configuration here. But you can overwrite either by editing this configuration file /etc/sudoers, or probably you can, because this line is commented out. And then you can provide the line not commented out from another file from /etc/sudoers.d, which I didn't know it's a possibility, but sounds really great to do. And now if you create another Linux user account on this computer, and you should have an administrative Linux user account, so not a user root. And that is administrative because it's member of the Linux user group named wheel. We don't have PAM yet, and we should probably install PAM. Okay, and now search for Midnight, MC Midnight Commander. Okay, let's see, where am I? In the sudo directory, go to the parent directory, clean up, wget, Ctrl+Shift+V. Let's see what dependencies it has. It depends on the GTK library glib and also wants slang instead of ncurses. I'm not sure why it wants that. So let's do slang first. Maybe this is easier. Depends only on oplibpng. Okay, so let's do slang first. wget, Ctrl+Shift+V, pwd, star, xvf, lang, cd slang, configure and make. We're not going to run the tests, and then we're going to run make install. Okay, make install. And that's it. Go back one directory. delete the slang directory, and back to where we were, glib. Let's see how many dependencies the GTK library has. G-object introspection. There's a patch. Docutils, lib, xslt, pcre. Wow. It depends on everything. And MC requires that. Not sure why it depends. Does it depend on the G-object? And there's not a separate G-object release tarball. There's just glib. Okay, bad luck. We're not going to go and build Midnight Commander because that requires glib and that requires at least 20 others. And most of these libraries are graphical user interface centered. I'm not exactly sure how, if we want to configure them to remove all of the GUI bits and only be TUI centered. Okay, we'll do nano, the text editor, and then that's going to be that. Nano. Okay, doesn't say anything about dependencies. Tar xvf nano configure and make. Okay, and install. Auto indent, constant show, field 72, history log, multi-buffer, no help. Yeah, maybe we'll survive without these. We're in the directory /sources/nano minus version. We have some files in here. Let's prove that nano, the text editor, works by editing the readme file. And here it is. License GPL version 3. Control X, save Y, enter. Okay. We have everything. We've installed LFS correctly. We have booted inside it. Now, the only two things that remain is if you want to continue with the BLFS book, is to either choose a desktop environment and install it as per the BLFS book, or if you want to have a headless server and want to install maybe a LAMP stack, maybe that's available. Let's see. How do we search for that? Apache. So there's PHP and Apache and probably a MySQL or MariaDB server. There's MySQL, there's MariaDB. And with that you have a full LAMP, Linux, Apache, MySQL, MariaDB, PHP, Perl, Python stack. And with this you can host websites that are either static files or server-side rendering plus JavaScript. So there's a ton of features out of the box there. And you probably have additional databases. I have seen SQLite. and maybe a PHP management application for instance, MySQL. PHP MyAdmin. Let's see if that's available. Nope. Additionally, I'm going to try to see if one of the fetch alternatives on NeoFetch, FastFetch, that's only written in shell, for instance, works and supports this operating system. Let's see how that works. So where am I? In sources nano. Okay, let's download a release, if there's such a thing. A release tarball, tar.gzip. tar-xvf. This is NeoFetch. Wow, wrong name. So let's rename this thing first. Move 7 to NeoFetch minus and then this thing. tar-xvf NeoFetch cd NeoFetch, and there's an executable there which is called NeoFetch. No need to install anything. Yes, Linux from scratch, x86-64. So this was it. This was my YouTube tutorial about how you can install Linux from scratch. We have used a virtual machine. Hopefully you can reproduce all of the steps that I did. I didn't skip any steps. And I have split this long YouTube video into parts, the first part and the second part. This is it. Thank you.